panel discussion. As agreed, first I'll just throw some questions on the panelists, and then we will keep the house open in case you guys have some questions specific to what we are discussing now. So we'll start with the first question. As we have the mix of audience from India and abroad, how do you see the trends in structural steel industry in India? And probably Madhan will talk about something about Singapore. We have a couple of experts from Middle East, and we'll have the Indian perspective. So what we would like to know first, what is the current trends in structural steel? To what level we have matured in terms of design, engineering? That's what we'd like to know first. Yeah, we can start. We can start from that.
Okay, thanks. I just want to say that the level of design maturity is there. It's just an opportunity. If given opportunity, Indians can do wonders. There's no problem. There is a lack of opportunity. And as I said in my presentation, the most brainy people, they do come from India and Asia, and they do tall buildings all over the world. And if our regulations are such that we can build more than 300 meters. Today in Mumbai there is a restriction because of the airport, radar and all that. I mean, if you can build 300 meters, World 1 is already going beyond 500 meters and all that. There's no limit. I mean, once you get the knack of designing tall building, you can definitely build tall buildings. Tall buildings means steel structures. I mean, although Majid said that the trend is coming down to concrete buildings, but I think as you go taller and taller, there will be no choice but to go for composite. Composite, in fact, his slide showed that composite was getting more popularity. And I'm of the opinion that we need not go for 100% steel structure. We have to have a very intelligent combination of the two materials, which are fantastic materials. So opportunity is there because India is going to grow. More and more buildings are going to come up, both in housing sector as well as tall building sector, because we don't have many. So we have to only go up. Opportunities ample.
Thank you. With respect to the design expertise in India, I think we had ample design expertise. But with respect to the codal provisions to be followed, I think our codes need to be more stringent, and we need to also increase our expertise in the younger levels. Like somebody was pointing out, 23-year-old Koreans are doing much better designs than what our engineers do it. One is the level of exposure, and other is the training to be given for the young engineers who are coming on the board for starting their career. I think this is one area where we are a little bit lacking. I think we can improve further with a focused training in each and every company. Apart from that, the codal standards, like we are looking for American standards or British standards most of the times when we do the steel structure designs. And I think our codes need to be upgraded. As 800 is a good move now, it's on a good standard now. But still we need to go further, and also like deck sheet, we need to standardize on the codal provisions there. Somebody has pointed out. Apart from that, fireproof painting. So all these need to be put in the standards so that there is no much variation with respect to the specification being followed out the industry. And this is what the way forward. And I'm sure when we meet next time, we'll be able to have some standardizations and also some more flexibility in terms of using the fabrication facilities, which is now another dearth of availability. So once we have this couple of additional facilities, I think we can pitch in much higher level for the structural steel in all the buildings, whether it is tall structures or whether it is a ground expanse or large roofs, span roofs, anything you say, I think we can do it. We can do it. That's right. Thank you.
Madhan, what are your views? How is steel accepted in Singapore especially? We have seen some fantastic structures getting
fantastic structures in Singapore. Yeah. Recently, the Gardens by the Bay.
Yeah.
It's having an internal garden.
Yeah.
The structure is something like architectural irregular structure, completely made of steel, and the panels is all made of glass. it's a fantastic. There's a lot of steel construction going on in Singapore. But I also want to talk about from software vendor point of view. I can see many speakers here, industry experts here.
Yeah,
of course, I can't talk from industry point of view. They're already experts here, sitting here. But I can talk from software vendor point of view to simplify the workflow in design offices. Right here, sitting here, I can see many of you use different software vendors. One for detailing, one for analysis and design, one for connection design maybe, one for foundation design, one for BIM, for multidiscipline modeling and interference checking, clash detection, schedule simulation. There is neutral formats available like ISM, Integrated Structural Modeling, developed by Bentley, and is useful not only for Bentley softwares but also third-party softwares like Tekla, Autodesk Revit, etc. So using that standard, you can use a single model created in one detailing software or one analysis software and exchange the same model to other softwares. A few button clicks, offsets, and that can be ready for detailing also. So this way we can simplify our life in our design office by reusing the same model built in one software in one vendor and exchanging the same model in other vendor softwares. That's from my...
Thank you. Mr. Shah, your views on steel construction?
So obviously, I do believe that that's a way to go, particularly in Mumbai and cities which are which have land bank which is very, very scarce. Also, there are a tremendous potential in terms of using steel even in design. So it's not necessary that it is only for high-rise. I do believe that there is tremendous scope in terms of trying to enhance whatever we are doing and thinking. Particularly with new softwares, it's much easier, faster, and to execute it is much faster. So there are multiple advantages, there is no question about that. So one uses prudently all the technology and try and put these together. I'm sure in a couple of years things would be completely different here.
Sir, your opinion, please.
Yeah, steel is the next generation, this thing. In India especially, not abroad. Abroad they've been using it for decades. But in India we are still not attuned, one being the price, second availability, which we have overcome that till now we didn't have the proper availability. We didn't have the proper contractors to execute it. Now we have all of them in place. It is only one of the other major factors is the cost. So we have to do something to the cost. If we can do something to the cost, I think it will become practical doing steel buildings. Another factor that is there in Mumbai especially is our approval problem. So we do not know, I mean, when we do a building, we design a building, the developer comes to us and they say, I'm going to get 3 FSI, I'm going to get 4 FSI. So he's also not certain. There are so many, if it's a rehab, this thing, there's a slum, he says, this will become Patra, this will not become Patra, so I will get 3, I will get 4, he's not certain. So, but in steel, what happens is you are doing the drawings and the steel gets fabricated, everything off-site, and you bring it on-site. So it becomes a little difficult with that kind of a scenario. Whereas when you do concrete buildings, it's you stop it where you want. So that's another issue that we have in India still. So, but we are getting there. I think if we can control the price. The other one is your fire rating to the steel. The other thing is, as he rightly pointed out, is if you do a composite, maybe you do the slabs in concrete and the columns in steel, so you don't have to do false ceiling, because we are still not attuned to do false ceiling in all the buildings. We like to avoid that. We want to put the conduits inside the slab. So it'll take time, but I think we're getting there.
I'm going to take the discussion discussion a little away, because I want to approach it only from the point of view of design. There are problems, there are issues which we all have to overcome. Industry develops. I'm sure that was the case with concrete when it was introduced too. What I'm going to try and get at is design trends in steel in India are changing. Architecturally, we are, as a designer, I'm looking more towards using steel where appropriate. Now, why I want to use that word appropriate is because when you start thinking of a design, you also think of building construction materials which are going to reflect into that design. You want to make it a holistic, total idea, a unitary idea. So in that sense, well, the industry is going to move a long way. The trend has started, it's going to move a long way. Steel is not to be looked at as the building construction material for everything. It's not going to happen. Therefore, if you start asking the more relevant questions, whether it's the right material for that particular project, you'll find a cost-benefit analysis will give you the right answer. You're going to use it that way. You're not going to use concrete everywhere. Similarly, you're not going to use steel everywhere. But the steel in itself as a material internationally has been used very well. When I looked at, I was in architecture school at that time, when I first saw the George Pompidou Center, and it just blew my mind. It was a building literally inside out. It had steel detailing with every rivet, every bolt, every pin, so well articulated. I felt that, I mean, it's been done so many years ago. I felt that was the way to express a construction material. And it started with an idea of having the entire architecture being literally transparent, being honest. So honest to the material, to the design intent. It was, it's a museum and a cultural center. So it's basically, you should be able to relate from outside in and from inside out. So they had these large span structures. Now that level of detailing, that level of involvement in the fabrication, in the design detail of steel in India is still not there, but I'm sure it's going to get there. It's just a matter of time.
Dr. Pradyumna.
It's nice to hear from architects and consultants. I'm neither. I come from the construction industry, and I think I am probably fortunate to be a design and build engineer, not a designer nor a builder, a design and build engineer. And I've been seeing the passion that we have for excelling in what we want to do. We have been able to do it only with steel. And we have found that the education system that is there in the country, there is a drastic change that is needed, because what we know doesn't come from education today. It comes from experience, it comes from observation. And then when you get students coming into for an interview, even with 5 years or 10 years of experience, we find that they are all fixated on RCC and they are fixated on STAG today. This is something very disturbing, and probably I would say this is one of the reasons why, even when architects are able to visualize some really grand designs, the implementation is disappointing, and then, so what happens is the media, that is the people who actually implemented it, they have failed somewhere. So the end result is the owner or the architect doesn't want to experiment more in the next project. So this is a disappointing trend I have been seeing. Where we go, we get very good reception. And some of the project which we did for Reza Kabul, even today is a landmark for us. It's appreciated because we did the hard work there. But I'm not seeing that in the current set of engineers who come. They are good designers, but we believe that the design is only about, the structural design actually is about only 10% of the effort and the remaining 90% goes into the post-design activities. There are so many things. Bentley system, they are saying they have a software for BIM, fine. But then we have found that an engineer to be complete has to know not structural engineering, but he needs to know mechanical engineering, he needs to know software development, he needs to know everything. There is no, structural engineers are really fortunate in the sense we don't have any boundaries that this is something I can't do, that is something I can't do. You put your mind to it, you can do everything. So I feel this, the education system, you need to bring some change there. Then there are enough people who can take these things forward.
Sir, what are your views with your experience in Middle East and in India?
I'm not going to talk on design and things. I think there are much better people here. I have no clue on that subject. Only one thing, because I've worked in India, I've worked abroad in many countries. The biggest problem, and I've handled India as a market for various mills from around the world. Cost is always driven by the supply mechanics. Okay? Today, structural steel, I'm talking of hot roll structurals, and even for that matter, plates or anything which you do build-ups. It is so difficult to find good quality structurals in India, even now. There is one JSPL. Fortunately, next year, I think Steel Authority of India is going to come up with a big mill. If that happens, then the cost equation which they are talking of probably might change. Secondly, we have so many taxation laws in the country, which I never understood even when I was here. Now I don't understand anything. There is 29%, if they import a material, say you import a jumbo beam, the gentleman has to put, somebody was saying, somebody from Zamil, I think Mr. Alakesh was saying, there is 29% extra levy on it. How on earth will the material be cheap? If you want to build 100 smart cities in the country, I think you as a team of designers and architects need to approach our PM, who is accessible apparently, and say that this is not the way you levy the construction industry. It will never propel itself. If this is the cost structure, people will cut costs, you will not get quality in the system. I mean, I think ease of access of material, and he took up the issue of people learning, I also said that and think, is very, very important. Thank you.
Actually, although I'm from the Middle East, I have spent more than 3-4 years continuously in India. So I'm aware of the market and the issues. Actually, I believe that for promoting steel in India, you have majorly two issues. One is the availability of fabricators and suppliers. We have a very major shortage in this. What I mean by fabricators, I'm speaking about quality fabricators of structural steel. I'm not speaking about people doing handrails. The other thing is the availability of raw material. Mills are very limited. As Mr. Venkat spoke in his presentation, the amount of the production of steel in India compared with the population is far lower than developed countries. So we have a major shortage in this area. And under this shortage, the only way to excel in the construction industry is to import some sections. But having this kind of custom duties, it's too much. How you can do that? As he said rightly, the Indian construction community have to approach the government to reduce this. I understand that people can put custom duties to protect the local industry, but that's fine if the local industry is enough or adequate to handle this market. But if you are having already a very high shortage in the supply, then there is no point in preventing importing material to the country. That doesn't make sense. On the contrary, you are trying to cripple the industry by not giving them the best options to excel. The other point, as Doctor mentioned, is regarding the education system. This is very important. Actually, this is not in India only. We are operating in many countries in the Southeast Asia and the Middle East, and we are suffering from that particular point, that the education system in all the regions, Middle East, India, Southeast Asia, is not really targeting developing or producing engineers who can understand all this. A structural engineer mainly focuses on the structural design. So he knows only how to put a load and design a beam. But he doesn't know all the aspects around that. How to make this design shop friendly.
you can produce it easily, how to make it constructible easily, where to put the joints. All these kind of experience we learned over years, but there is no orientation in the education institutes to try to give him at least the basics of these kind of things. By, for example, giving some sort of summer training in construction companies, something like that. The students have to get exposure to start at least having the basic skills on that. Of course, later on they will develop the skills by experience, but they have to know the basic. They have to know that these things exist. Unfortunately, they come out of the college, they don't know anything about that. And we are suffering sometimes in certain projects where you see the designs coming from the consultant office done by junior designers, which is totally not practical. And for example, in one project, without giving the names, the designer have used in one building, small building, maybe 200, 300 tons, not a huge structure, more than 140 different hot roll sections, which it doesn't make sense. You feel that the guy is purely theoretical. This beam is 2 meters, the section is that much. This beam is 2.2, the section becomes slightly heavier. It doesn't work. Then practically to produce that structure, it becomes a very heavy burden. It takes time, the wastage factor is more, everything is not practical. So yes, we have to take care of the education system. This is part of the thing. But as I can see, there is a big scope in India for the development, because already there is a huge market to develop and expand in, converting a lot of structures from concrete to steel. And as previous speaker said, this is not replacing concrete everywhere. Of course, concrete has to be there. Even if you have a steel building, the slab is concrete in any case. So, but it's a matter of really getting the right material for the right structure. That's it. So I think there is a big scope, but we need mainly, as I said in the beginning, to develop more fabricators and suppliers and to have more mill capacity in India. That's the only way to go forward.
May I add one thing? I do strongly believe that one component which we need to look at is time. Cost is important, but you need to give value to time. And once you look at time, the structural steel not necessarily would be expensive in that manner if it is executed properly, if it is planned properly. Though there is an issue in Mumbai about logistics, but principally one can really look at time, and that would really compensate substantial amount of the cost, which so-called expensive nature. That's what I think.
Sir, each one of you interact a lot with the owners, the developers. Do you see a certain amount of urgency in time that is coming in, or still there is like, we have sufficient time, no need to rush up? Do you feel somewhere time is playing a major factor? Because if you use steel, yeah, definitely it will save time. But are companies serious to save time?
So actually, he rightly pointed out, we have a serious issue with the approval processes. And that really makes things very, very difficult. We never know when can you start. We will never know when do you need to stop. The processes are such, you finish some process, you need to get reapproval. So I guess these things need to change to ensure that a proper process is followed. That's what.
We started on a building in BKC, and it was about 8 lakh square feet. We proposed steel. We got one of the leading steel companies to come in, and we worked on it for almost 3 to 4 months. I think maybe 6 months we worked on it. It was a commercial building. We designed the whole thing. We excavated the basement, and the commercial bank rent came. The order was given to the contractor. The steel was being cut in the factory. The client just dropped it. He says, I want to go in for a residential building. So you can imagine what happens in India. But like abroad, it's not like this. When they decide a commercial building, that's it. Whether downturn comes, anything happens, they will do it as a commercial building. But here we are still not attuned to this thing. So the steel all went waste. Of course, they'll reuse it in some other construction. But this is what happens. And then when you do a residential building, nobody wants to go in for steel. So.
Are we somewhere suffering from the mindset also? Like we are so comfortable?
Yeah, because you know, that's the human nature. It's like you're doing something every day, so you don't want to explore, and that's why people don't want to get into steel. But there is still a barrier for that. But the other thing is the developer doesn't want to put in 30%, 40% into steel at the inception. They take it, okay, I'm going to book the concrete, I'm going to book the steel for your rebars and everything. It comes on site, I've done my raft, I pay for so much. Next comes this. Whereas in a steel building, you've got to go all the way through. So, but the mindset is there, financial. In India, we still do not have a lot of the capital investment people. There are developers who have got, but the other ones they haven't yet got. So they have to do their own funding. They have to sell and they have to do their funding. So that's that's what is stopping them from doing steel buildings.
In fact, I support Reza because more than 60% of the steel buildings that we have designed and they got materialized were for the own use of the owner, where he had clearly in his mind why he is building the building. Whereas many developers, he cited one example in BKC, I can cite another example where the building was designed as a commercial building, office building, and the developer purchased the first lot of 8,000 tons of steel. And that building was, abandoned because the market changed and that building was converted into a residential building. And that steel was of no use. It just was lying in a yard, for 4 years. And he had to sell it for scrap. Now, actually not related to this, but I don't understand. We talk of approvals needing the 3 years, 4 years. And how can, in a city, a commercial plot can be, transformed into a residential plot? I mean, who is giving these approvals? And this suddenly happens, So this is really a weird thing. But as I was saying, if a developer doesn't know what he is going to build for and who he is going to build for, still a proposal is dangerous proposal. But all the buildings, those are being developed for own use, they have gone into steel.
So I do believe that there is a change in trend. We are designing presently for steel residential building, which is 40-50 stories, so which is ongoing, and I do believe there is a change in perception of the developers and the whole.
Again, that is self-use building.
No.
Ruchir sir, I remember you mentioning once for a hospital you guys have used steel, and I think that was one which went through a little smooth because the investor himself wanted to get it constructed on time for
No, it was just about time. There were two aspects to it. We looked at the feasibility of designing hospitals and building them out of steel as a primary material because of two aspects. One was, of course, the time, but that wasn't the overriding factor. The overriding factor was, this was a chain, I don't mind naming it, it's Walcott. They had around 6-7 hospitals which were all coming up, and they had already built two. The one in Bangalore, which suddenly got an extra FSI, 1.75 FSI. Now he can't consume it because he's already constructed his building in concrete. There's nothing he can do other than build in steel and hope for that differential or the factor of safety to be able to take care of that. And he also realized, the chairman is quite a smart person, so he realized that this is happening across the country. The FSI is just constantly going up. And a healthcare facility cannot be disrupted. It cannot be shut down, demolished, and rebuilt. Any other building can, but a hospital can't. So what he came up with was a whole study to be done where the feasibility of structural steel, irrespective of the cost, whether that would be a viable solution where you factor in a little bit more in the lower floors, and then you can keep adding it as you go up to a 0.75 times constructibility. So he even had a factor of how much is the over-design factor put in the lower floors and how much money he's locking in for what period of time. And all that for a 3-year period, 5-year turnaround, everything was worked out. And he, in the end, found it was a no-brainer because the amount of returns he gets, because the land prices go up over a period of time, and the locational advantage of a hospital which is up and running and being expanded is far better than going and buying another piece of land on the outskirts of the city and then running from pillar to post to get your basic infrastructure and amenities. Like power was one big issue, even in a city like Bangalore. So all these things put together, steel came out to be a better solution. Plus, a hospital can be standardized. So the steel design efficiencies were also worked on in terms of standardizing the format for the entire hospital, right from the structural grids, which went from the OT to the rooms, to the ICUs, and down to the parking. So even the parking grid is efficient. So that was a whole study. It was done over a period of almost 3 months. We came to a conclusion steel was a better solution.
I have had some interesting experiences in this. We have met some developers. Their thing is very simple. If I have to do a steel building, the contractor, I'll ask him, give me money to buy the steel, the entire steel, right? Because suppliers of steel, manufacturers, they want 100% advance most of the time. Otherwise, they want LC, 30 days LC or 60 days LC based on the past relationship we have with them. Now the developer says, I have to invest so much money in the beginning, and then for about 2 months or 3 months, he doesn't see any activity at the site, except for some foundation, something popping around there, excavation and thing. Okay. And then he has to wait for something to come up because he is answering to somebody else who is funding him. And then he says, if I do an RCC building, what is my cash flow? I do excavation, I pay him. He builds the rock foundation, I pay him. He brings concrete up to a certain height, I pay him. The cash flow is fairly uniform. Whereas in a steel building, the cash flow, there is a bump right at the beginning. We ask for 25% advance, 30% advance. Developers are not willing to shell down that. Then he has to sell and get money sometimes, if it is a residential building. You would rather wait, okay, 4 floors have been built and he sold only 3 floors. So he goes now on the construction. Time is of no meaning. Now we talk of time when we do a steel building. For him it has no meaning. Because if he is not able to sell it, why should he hurry up and build the whole thing? This is only some developers who are building on the outskirts of a city. But maybe inside the city there is no space or anything. There steel has been a very good alternative there.
Anybody wants to add? Yeah.
As referred by Dr. I think steel building, when you want to construct like that, you should always, you not have negative cash flow, always will be positive cash flow, which is one of the major hindrances to putting the cash upfront and then deliver the material. Because any LC or alloy, they provide the, they give the bills only after supply the material to the sites, which is a very bad practice as of now, which is being followed. But then if you can push the advances maybe to 20-30%, which may help the industry to come up faster to get the material and not to suffer on the negative positive working capital. And that's what we're looking for.
So actually in city, a couple of projects which we are doing, there is what is called as rehab tenants. So there are 200 of them, they need to be moved out. it becomes prudent to get them out quickly, get them back quickly. So I do believe, at least in city, we have found that cash flow usually is not the major crux. It's critical that you finish your building quickly, get them back.
Because if the faster he builds, the faster he gets to do his sales performance. So he needs that.
This is not relevant to India, but if you go to the developed economies, the way the steel cycle is supplied is it is not the steel mill fabricator circuit which goes through. What goes through is a steel mill, service center, and then fabricator. There is a circuit like this, especially in the developed economies, where what happens? Why do you need 30%? Because invariably the fabricator needs an advance to buy the steel, in case you're going through a fabricator. And that's why he puts the load back on the developer, and that's how it happens. But if the fabricator has a buffer in between, which has a steel service center, then the deliveries are more or less on a day-to-day basis. Then this 20 or 30% advance business reduces. But in India, we have a basic problem. We have very few fabricators itself, let alone service centers. So we will have to suffer this for some time till the industry matures. The industry overall needs to mature, the supply chain will mature, then the cash flows will start happening, the developers will see wisdom in what they are doing. Only then this will change.
In fact, I have promised we will open the house for question answer after this last question. So please be prepared with your questions. I have this one question. Why not? What are the key challenges with steel that it has not been used extensively in our buildings? So we would like to hear something negative about steel.
I can say I'm sorry.
Because we don't discuss that, we can't capitalize into and work on it. And
I think majorly it's the cost. That's the point. Presently, I think we are not able to realize the importance of time in some of the projects, and we give more importance to the cost than the time. And we try to say that cost just because going for concrete structure, and then it is the time which matters cost, like he was pointing out of the approvals and all. Finally the total time for the project is going to be the same, whether you take a steel or concrete, so you lose with respect to the cost anyway. So knowing this, I suppose, my understanding is that because of that particular fact of not able to save the cost, they are not going for the steel.
Sir, I have just one question. You had an interesting project, the new international terminal. You completed that in time, yes?
Can I be real? Okay, let me tell you that. We have a bigger subsection in the middle of my terminal, which is a statue, Shivaji statue, which is an important statue for this region. So shifting that happened only in August 2011. So further we don't have buffer. So there we had our own difficulties in constructing till such time. But we could cover a lot of areas on the terminal part of it, and then balance was not a big problem. So this is a blessing in disguise, you can say. But coming to the actual part of it, steel took a lot of time there. But we have erected total stock steel of 18,000 tons in 1 year, which is not a normal condition in any of Indian part of it. So, but erection is fine, but then getting the material from all the sources is the biggest task for us. I was explaining the logistics part, getting it from China, Singapore, or from India, all. It was he was brought up part of that also. So it was a huge task for us to get the material first. Erection is never a problem there. Fabrication also is going pretty fast with all JSPL support. But erection is never a problem, but only material logistics and storage at the site. But we did lose some time because it is steel, but then it is covered up in a different aspect. So that's it.
So you have a new visiting card for the steel, and just in case you need.
So what are the challenges, especially from designer? Because you are mostly part of the project team, the owner who drives the entire project. So what difficulty have you faced as far as the feedback from the industry in terms of steel construction?
I find what is lacking is the fabrication, the quality of fabrication. The finish is very key, and the longevity of the material in the end. You don't want something which is built, looks really good first 2 years, and the third year it's rusting, streaking, all over the place. And that's been a problem wherever we've used it. And then, structural steel being used only structurally. For example, my friend there from L&T, I was involved with the Hyderabad International Airport, and we designed a leaf truss as a skylight because the roof had a profile like that, and then the shape of the truss was that of a leaf. And L&T simplified it into some ugly looking thing. So I think it's all basically level. No, I don't blame them because they said, well, the rest of it is all just going to be cladded. Yes. So why the hell to waste so much of time, effort and money? Now, I had a counter to that, and that is, if you look at the space frame system, the Miro and the Modis systems, they designed the junctions. They were all die-cast nodes. And they designed them aesthetically. The tube was made tubular, it was tapered, it was threaded. So it's an approach. If you do a bottom-up approach, right from the choice of the material to the application, end application, and then do the whole design process integration, the result will be beautiful. But if you do it as a standardized process, which is, okay, I'm going to cut and weld and chop and, put together, then I guess all the other issues will become relevant.
I agree with them. In a sense, the projects where we have done, we have been able to drive it. In a sense, we are able to tell the architects, this is the specs you have to use, this is the way we need to go. And those projects have come out nicely. Where we come in like another fabricator, there is a specification which is laid down, this is a painting, this is a structure, this is how it is. Then we have nothing to say, and then the structures are built, yes. But some of the most, I don't want to comment it, but same L&T's T2B, if you open the cladding and you see the structure.
I think I would like to confirm what they are saying. It's not the confirmation rather. I think people should understand also client aspirations. Apart from we propose something, at the same time there are other priorities like time you'll have and the cost you'll have. India, that's what I was saying earlier. We want to build up a steel structure in India, expose, and at the same time the client is not able to spend time or money. So you have some compromise in the intermediate stage, but this is the way forward. We're looking forward to get a much better steel building. That's what I think.
I have two examples.
I just want to add this. They did a project for us. They did rather two projects for us, and one was really an interesting project. It was 40,000 square feet of atrium covering, and when we put it to the client, we want to get this done. The client was reluctant because I'm talking about 10 years back, I think 8 years, 10 years back, and the roof covering itself was coming to 3.5–4 crores. So the client was a little reluctant, but somehow we convinced him, and he had liked the design, so he said, we'll go ahead. And when he gave them the money, the advance, initial amount, and for some time there was no work going on, the client was getting frustrated all the time, because they did an excellent job, I must say, because they did it professionally, and it was a free-flowing shape. They came on site after 2.5–3 months, and then actually everything started on site. But it was actually erected in the factory and it was bought here. So it was like he said, it was all molds and just bolted. It was like a mechano. Everything was so professionally done. They had all numbers on each tube, each node. And we had a glass, which was a laminated glass. All shapes and sizes of the glass was different. They did the whole thing and they brought it on site and it was erected. And that was the time when the client said, yes, it's good job. Because to till 3 months, 4 months, there was nothing going on site, and the client was very frustrated. He kept on calling us, and we used to have bad discussions and shouting and this and that, but the end result was excellent. They did a professional job.
I just wanted to complete what Surya Prakash had just said. You know, let's go back a few hundred years. The Eiffel Tower was built, we all know when, and we all know why. But it wasn't approached from the cost perspective. And that's why, in spite of the fact that it was just a gateway to an expo, and it was supposed to be torn down, it still is where it is. And it put Paris on the world map, you know, in a visual way, just as the Burj Jumeirah has put Dubai on the world map architecturally. No, the Burj Khalifa is the, I'm talking about the hotel. Yeah, and of course the Sydney Opera. Now all these buildings, if you look at it, they were all, you know, I'm sure not the most cost-effective solution. They were the most appropriate design solutions, and that is why, and you'll see one other common aspect. Eiffel Tower has paid itself off, I think, many, many times over in terms of just tourist tickets. The Sydney Opera, John Utzon, who was the architect, he had sworn never to go back to Sydney. And when they had a centennial or some sort of celebration, they invited him, he refused politely. But they actually did a study that whatever were the cost overruns which the Sydney Opera Committee had listed down, there was a 10-fold payment only in terms of royalty for photography and postcard sales. So, you know, what are you talking about in terms of cost? Just make something beautiful.
I agree, but that should be the client's perspective. Yeah, that's when you're making a monument, when you're making a residential building. Second, because you require to put it in the client's mind that this is going to pay you back. Maybe we are not able to convince them as a designers. Yeah, that's right.
Sorry?
By the way, the Eiffel Tower when it was made was not a very light structure. It was very much hated.
Over the period of time you get it all.
What is the weight per square meter of the Mumbai airport?
That's what I said. Be able to convince the client to go for that. If you are able to convince the client to do it, he will do wonders for you. So the all point lies that, do you want to create a monument? If you are able to convince your client, the yield after some time, he'll be able to agree with you and start going for that. That may be the case of Eiffel Tower or any other monument structures. Maybe SOE is coming Statue of Unity. Maybe that's the point. They want to do like that.
In fact, I have a question for fabricators especially. Now, there is an interesting fact that have came up. You know, how we can assure a steel structure to look, after a few years, look the same. Probably what we can do while we are fabricating it. Are we using some technology to make sure they look glamorous as they look in the first year?
Like any concrete building. I think in the break also somebody was actually mentioning that. Every steel building, if you are enveloping it properly, absolutely it looks same. You can able to go and then see all the building constructed using wood material. Proper material, it looks same because it has got the protection, environmental, UV protection inbuilt with the panel. Everybody will agree. It's one of the USP for the steel panel. It's going to look as is after 10 years.
Is it true?
Yes, I can show.
Yes.
I think if you want, we can able to separate it, display support specification. I can able to give you. There are enough specifications in the market says You have to use some kind of, you have to pay some kind of premium to get the, of course, no, if you are going to really make the building look, no, these hotels are built, the same cost of building this hotel is not same like a residential property.
So,
it's going to be totally different.
In fact, the process, that's what I'm trying to touch base on. Do we have to...
Just to give you an example of the skywalks what are made in even around Mumbai. I'm sure if you look at it, they have started resting at the places.
So we have to put a process in place. Do we have any process to make sure that longevity is there as far as looks and...
Actually, it depends on the requirement at the end. And there are various types of protection to the steel, starting from the normal paint up to high built epoxy, up to polyurethane coating, up to sometimes go for hot deep galvanizing, then painting. But at the end, everything needs a maintenance, okay? We mean look architecturally, and for example, even if it doesn't rust, if you keep it in a petrol station, let us say in the street, because of pollution and dust and everything, after 1 year, it will look dusty, it will not look bright as before. Then it needs to be at least washed, you know. It has to be cleaned. But from corrosion point of view, even paint suppliers give you a certain period. For epoxy painting, they give you like 10-year warranty, 8-year warranty. So after 8-10 years, still you have to make some maintenance, repainting, whatever. There is no paint in the whole world which will last for 50 years. This is not, doesn't exist.
You have to maintain. End of the day, you have to maintain the structure.
We do have some, ways of ensuring the longevity. What we require is the sections that are available today in the marketplace are not very, conducive to making these sections be embedded inside. The cheapest way of maintaining steel is to cover it with concrete. That is composite construction, right?
No, I like that differ here because if you just go, all the coaches, railway coaches, flying everywhere, open to the environment, correct? They are not rusting. Why? Copper rich steel, please try to understand. We can able to make steel building.
Gentlemen, you can make steel corrode a lot less faster. Yes. These are called weather resistant steels. Normally it's brand names or something like cotton and stuff like that. So yeah, weathering steels, you need copper and a little bit of chromium in it, but you need to pay for it.
Yes, exactly.
You can't have a cake and eat it too. Yeah, it's very simple. You have to evaluate.
Put anything, use stainless steel.
Very easily. In fact, can I tell you something? There are some ex-startup people here, I think. Forget sections. We used to try and sell rebars, corrosion-resistant rebars for the coast. I don't know whether you guys still sell it. We added copper, we did seawater testing, we showed it to all the consultants. We got a response, "Ye to zameen ke andar ja raha hai, kya farak padta hai?" You know, it's going inside the ground, how does it make a difference? So, because we were charging an incremental amount for all the effort which had gone in.
Now all steel is corrosion resistant. In rebar, everything is corrosion resistant.
So, do we have any questions from the audience? Wow, this is interesting. Sir, please start.
Good evening to all of you. When we were talking about cost as well as we were talking about making monumental structures in India and heavy engineering plants in India, we were talking about economizing by using IS 800-2007. We haven't touched upon the chapter 12. And the connection requirements which are most of the normal factories in India which are done today, they say normal, I mean not very heavy engineering, they say we exclude chapter 12 which require very heavy connection details. So can you please touch upon this point?
Bankruptcy maybe.
Sorry, I was a little ignorant. What is this chapter 12 here?
I know about chapter 12, yes.
This chapter 12, mostly the pre-engineered building manufacturer in normal factory, they say we exclude chapter 12 because the moment we say chapter 12 IS 800 2007, the connection becomes so heavy that the connection should not fail. So the chapter 12 says your connection details should be such that the plastic moment carrying capacity of the section should become 1.2 times, that is 20% additional.
Yeah.
We are talking about 1.2 MT.
Yes.
That's what I was asking. And in very heavy engineering plants, like the one which we are handling at present, we cannot ignore chapter 12. And our connections are becoming so heavy that the bolts are going right up to the pile caps.
Actually, chapter 12, we are well aware of chapter 12, of course, and it's not only limited to the connection, but as well to the dimension of the section, like the ratio of H over T and B over T and other things. But the problem with the Indian code that they have copied most of these provisions from Euro code and the American code. But the original, from where they have copied, they have missed few things. In the American code, they tell you that when you use chapter 12 requirement, there is a way out if you use the response factor for seismic 3 or less. So if you are using response factor 3 or 2.5, you don't have to design for chapter 12. So rather than going for 4 and 5 R value, you go for 3 and exclude chapter 12. That provision is not there in the Indian code, but it's available in the American code and Euro codes. So practically, sir, in India have copied something.
Sir, what has happened? Sir, what has happened in this particular structure is that if we reduce that to R equal to 1, you said less than 3, and the building importance factor is 1.75. So the loads have gone 1.75 to 5 times. So the structure has become that heavy.
No, so you don't have to go down to 1. And going to 3 is fine. And the American code says clearly in the seismic provision in the preface that if the R value is 3 or less, these provisions doesn't apply. Finish. So you don't have to go to 1.
But then the forces are going too high.
But I understand, but again, it depends on the nature of the project. Yani for example,
it's a heavy engineering plant.
Yeah, I'm referring to our PEB structures and other things where the seismic loads are not that critical. So practically, multiplying the seismic loads by 1.5 or 1.7, it doesn't change the design much. And it's far cheaper than increasing the connections and dimensioning of the sections and everything, because the requirements are too heavy. From our experience, applying chapter 12, the structural steel weight increases by 25 to 30%.
Yes.
Jumps up. But of course, for buildings with heavy weight, heavy seismic forces and other things, this is a different story. We're not speaking about high-rise buildings. For high-rise buildings, of course, you have to apply this. But again, when chapter 12 requirement was copied, it was copied with, again, exaggeration and the safety factor. Yeah, so practically the American code specify this has to be 100. The people copy it and make it 120, not 100. They start embedding safety factors in the middle. That's why chapter 12 becomes even more restrictive than the original.
Yeah, it is very restrictive.
Than the original requirements of the American and
And what happens, because now to economize on the top structure, the designer goes in for chapter 12. The moment he reaches the connection, he finds that difficulty. Whatever he has economized on top, he spends in the connection and the foundation.
And actually chapter 12 was introduced only in 2007. Yani in IS 1984 you don't have these kind of chapter 12 requirement. So actually for critical structures we try to convince the clients here to get out of Indian code, design as to American code. That's the way.
My understanding is like this, you know, we have a saying in structural engineering, the structure is as strong as the weakest link, right? So the people who have framed the code, I have spoken to a few of them. What they have found is there is a lot of cutting corners in design. So when you do a connection design, you know, he was talking about space frames. We have done space frame joints. We have designed them. What we do is this 30% or whatever you are saying, we don't put 30, we put maybe more, 50%, 60%. The reason is that there are some things which are unknown. In a structure, in a straightforward structure, you are probably able to predict with some intuition what will happen. In an RCC design, I mean, I have not done too much of RCC design, but I have seen this. A 450 by 450 column becomes 450 by 600, and 8 mm tar becomes 10 mm tar. Nobody, you know, questions it. Because there are too many things that can go wrong. In a steel building, not much can go wrong. But then the flow of forces, the way it is, now what happens is if there are some lack of fit problems, or if something is fabricated a little less long or a little longer, or something like that happens, you don't know what is going to happen. So the framers of the Indian Code have designed, put this chapter 12, which I don't know, but I know this much at least, that you need to ensure that a common designer, when he makes a mistake, there is enough factor of safety built inside the structure to take care of this. Okay. There is a clause which says you can do a FEM, finite element analysis of that and actually design it. You can do that. When you do that, you don't look at this chapter. Thereby you get that economy. But then structural design is not about connection design. Yes, it is. But then it is about the form, what kind of form you have, what kind of section you are going to use. Use an I section instead of a box section to make the connection simpler. If you talk to, let's say, Girish and ask him which is the most efficient section, he will say a box section, which I agree. But then you put a box section and you want to do the connection design, you die. So when you come to me, I will say change it to an I section, which I have done. I have done it to Mukesh. Okay. So that is the reason why it is not about that. It is about something more. You need to look at the bigger picture, see how the structural behavior is there. What is the control you have over the fabrication process? What is the control you have on the erection process? These two play a much, much bigger role than a simple design.
Jansa, you have a question.
Yeah, actually I have a couple of questions, but I will start with a simpler one. We spoke about commercial buildings, residential buildings, warehouses, and a lot of industrial buildings. We also spoke about Empire State Building. From the same era, we have this Golden Gate Bridge. What I'm coming to is in bridges, why structural steel has lost its popularity or use. I mean, for that matter, we have Howrah bridges, or beautiful Howrah Bridge, beautiful Golden Gate Bridge. And some of the bridge projects in India, I'm saying, they are getting delayed like anything. So when we say steel is a material where the construction can be done very fast, very efficiently, and maybe with the technology available for fabrication, installation of bridges, using whatever modular concept or piece by piece erection, why steel bridges are losing its popularity?
Before any of the experts speak on steel usage, no, seriously, you guys are experts. I will only say one thing. I've traveled, you just need to travel to a country like Korea to see steel usage, especially in bridges, in everything they use. They are a country which is about, I think their per capita consumption of steel is somewhere around 600 to 900 kg per person. You will see that in every aspect of life, and more so in the bridges. They have double-decker bridges. I mean, not small lengths, 4 kilometers, 5 kilometers, that sort of bridges. Amazing. I don't know why it is not used in India. Probably you guys could. I don't know.
See, the thing about bridges, we have done a bridge here in Milan ROB. There's a 61-meter span steel bridge which we have done. There is a certain discipline that is required right from the time you start designing, okay, until you pull the final thing onto the road, wherever you are going to put it across. There is a certain discipline that is required. There is a certain passion that you need to put in, and there is, you need to put in a sustained effort. And like I said before, you need people who are able to do that, number one. Number two, you need people who are educated enough in the several aspects.
I would like to interrupt you. The bridges, what I was talking about, they were built almost 100 years back. So that time the discipline was there, and now it's not there. What kind of discipline is required?
Exactly my point. The education system that we have only teaches you how to design a beam and a column. Right? It does not. So if you want to know how to do the welding, then the guy is taken to a workshop, civil engineers. He goes into the workshop with great difficulty with the help of another welder. He does a little bit of welding there, and there ends it. But that's not it. You need to understand what are the welding rods available, how do you do that. There is an education that is required in that.
And just to, I'm from the offshore industry.
I know.
We have been, building and seeing offshore platforms where huge amount of building is there with huge amount of quality control, because these structures are going to stand in the sea. And throughout their 25 years life, they will be subjected to fatigue. Fatigue for welded joints is a very, very complex phenomena. And we have designed all the NGC platforms in India are standing for 30-35 years. So, and they were built so many years back. So technology is available, everything is available. I don't think welding or fabrication is such a big issue. This technology is there for at least, in India at least for more than 10 years.
Jansab, we actually tried to involve RDSO for this conference. Maybe next time I think we'll get them on board, and I think somewhere from RDSO I think it would be they will be able to.
See, India companies like L&T, they are doing offshore structures for the last 10 years, more than 10 years.
There is no.
And very, very heavy structures. They build 12,000, 14,000 ton platforms and 13,000 ton jackets.
I agree.
They are building their yard, topside in the Hazira yard.
I don't think it's fully that. We require to train the people to such an extent.
Very right.
That point is well appreciated.
Yeah.
We say put on everything education system. Who will do that? It's not education system. It's a training. What do you need to give to your junior guys who will come up with the trust?
Certainly. Any other quick questions?
No, just adding to what you're saying. I will agree to what you're saying. I don't know, all of you must have traveled to the US. Many of the bridges in US are very old, small bridges, not the long ones, even the ones which are interchanges, are all built with structurals. You will see a lot of bridges built with structurals, and these were built not now, maybe 40, 50 years back, and that's what Obama is being faulted now, that they are not investing in infrastructure.
All the small bridges
I certainly believe that he's right, in bridges, I don't know if there is a practical issue in making it, I don't know, but certainly that's an area which people can focus.
Does it have to do anything with the cost of the bridge? Because most of the bridges, they are bid by government, I mean, they are tendered out by government. And our system is the lowest bid. So naturally, any contracting firm, they will calculate the costs, and steel doesn't score. It's the concrete that is the cheapest material.
Okay, I mean, we spoke about the speed of construction.
It doesn't matter. I mean, why should it matter? I mean, I have traveled in Mumbai where a bridge takes 1.5 years to complete. I don't care. I mean, even if I care, nobody else cares. So time is not the factor at all here. It's the money. The lowest bidder gets a job. And I think it's the biggest factor.
Anyone with a steel bridge concept, why he's not coming out with this concept when the speed is there?
Speed is not required is what I'm saying. Even the contractor who is bidding, he knows the 12-month contract he can pull to a 3-year contract. It's not a problem. Nobody is going to penalize him.
In fact, I still remember Delhi we have a bridge which is fully done with the structural steel. The Namaskar bridge they call it. I think they are used.
I just started on one view. I just started. Apart from successful, molded techniques of the precast, launching molders are easy to launch. Apart from successful, the option for precast launching girders, which are becoming equally fast to launch the girders by doing the precasting elsewhere, which is becoming almost
They are scoring there. See, we were comparing earlier concrete versus steel. Now we are talking about pre-stressed concrete. That's right. So because they are a little expensive, we don't know.
No, and it's not still expensive, and time of completion also is becoming almost same. So you can't gain on the time what you will get in the buildings where you get a time advantage.
So
precast launching is much faster.
But precast girder requires its own queuing time.
That's right. They have the foundations to come up parallel with cast and precast. Once the foundations and brackets are ready, we put the bearing pads and then erect the launching girders.
We are really strapped with time and I'm getting constant reminders. One quick question in one line answer. What is the way forward? Where do you think the industry will go? Quickly, sir. How we are going to move up?
Strength to strength.
Fantastic. Which are the areas where we see the application will increase as far as structural steel is concerned?
Residential buildings, residential they are going to take off.
I think it's going to be in large span, in where traditionally concrete is not the option and is not the viable solution.
I think, as he rightly put it earlier, it's need-based, design-based, and that's going to govern the usage of steel or concrete or whatever.
I get tremendous scope. I would go back also. Architectural education is another thing which needs to be added with structural steel.
Education system talking before. In Singapore, I have seen the other way compared to their education system. That means they bring in the lecturers from the industry. Those who have 20 years experience in industry, and they pay more than them, and they bring it as lecturers in engineering colleges and universities. Okay. And future for construction trends is steel. I would say composite floors, reducing the dead load for the tall buildings a lot. So that which is yet to pick up in India, particularly for tall buildings. Yeah.
I think they have all said it, but I want to say something different. Through forums like this, we have many steel manufacturers, vendors and contractors, developers. They can fund some training programs which are not available in universities, or research programs. Those researchers may not be purely technical because we are all PhDs and MTechs and MEs, but research into where steel can be used, what are the social responses, psychological responses to use of steel. Such kinds of researches, if they are funded by these people who can afford to hold such seminars and in 5-star hotels, they can definitely fund some researches, and we should get the feedback from a larger society and drive, move towards those focused destinations is what I think.
And we have, on the education front, I just want to say there are a couple of institutes which are coming up, which offer some courses as a bridging between the employment to the education. So they, after completing the degree part, they'll have a 1 year 6 months course, which imparts industrial training as well as the site orientations, which are coming up now. I think many institutes are offering that, and that may make a difference for the perception of the youngsters, how to approach holistically for all the systems, including all disciplines. That's one which will take up. And with regards to our structural steel journey in future, I think mostly on the mega projects, you may get much more requirement to have a steel. Getting into office buildings or in residential structures, it will take a little bit time, but mega projects will have a bigger chance to get into much more structural steel.
Yeah, I think we need to make also the end users aware, or developers aware of the cost impacts, that the cost of the item is not the direct cost only. There is intangible cost, not completely directly. Finishing faster, time can be translated to cost. Actually, out of our experience, our first mall, which we have done in steel in Saudi, the concrete was cheaper. But we convinced the guy to do it in steel, although that steel was 20% higher, because he calculated that he will finish this project in 12 months ahead of time because of using steel, and he calculated the rent of the shops in these 12 months. He found that it's double the cost of the additional cost of the steel. So practically he's taking a benefit by completing early. In addition, of course, to the again non-tangible benefits like he have wider spans, less columns, and he can change his racks in the supermarket, whatever. Yeah. There is a lot of additional values, but we have to make people, I think, in India aware of this. But if the time is of no essence and nobody cares, and if the project finish in 2 years or 3 years, doesn't matter, then the approach should be difficult, and they will end up doing only, as he mentioned, the mega projects only. But to go for the residential part and the commercial part, office buildings, hospitals, and so on, then people have to understand the added value because of the time factor. And as I mentioned in my presentation in the morning, another factor coming in the picture, which is the green building. When you go green building, steel is a recyclable material, so practically it's more environment friendly against concrete. Cement is one of the most polluting industries in the world. So the less you are using cement, then you are reserving your planet.
Thank you so much. So thank you very much for coming in. Thank you, panelists. We had a wonderful interaction.